Hi, my name is Wei Zhu. I'm a graduate student at the Department of Astronomy at the Ohio State University. Today I will be introducing my recent paper entitled Predictions for Microlensing Planetary Events from Core Accretion Theory. Our work is the first one that introduces the planet population synthesis model into microlensing simulations. Microlensing is based on the gravitational lens effect. A massive object will bend the light of a bright background object. This effect can generate multiple distorted, magnified, and brightened images of the background source. In the case of microlensing, the multiple images are separated by such small angles that cannot be resolved from the Earth. But the apparent brightening of the source can still be detected. And since now the lens object passes by the source in a reasonable time, people will be able to detect the brightness of the background object as a function of the time, that is, the light curve. The idea of detecting exoplanets with microlensing was first proposed in 1991. If the lens object is accompanied with a planet, the planet may have a chance to perturb the standard single-lens microlensing light curve. By observing this planetary perturbation, we will be able to tell the properties of the planet. Here are two example light curves from our simulation. The planetary signature in the left-hand side light curve is caused by an Earth-mass planet with separation of 1.4 AU, while the light curve on the right-hand side shows signals of two planets, one with 2 Jupiter mass at 3 AU and the other with 60 Earth mass at 2 AU. Microlensing events are very rare and almost unpredicted. To detect one microlensing event, people may have to monitor 1 million stars at the same time. Detecting exoplanets with microlensing is even more difficult since only 1 in 10 of microlensing events show planetary signatures. However, since microlensing observations do not rely on the radiation received from the lens object, this effect allows us to study very faint objects which cannot be detected with other methods. As for the detection of exoplanets, microlensing can probe a region in the parameter space that is difficult for other techniques. The current strategy of microlensing observations is a combination of survey and follow-up teams. An example light curve as a result of this observation strategy is shown here to demonstrate the basic idea. The survey teams are monitoring hundreds of millions of stars but with low cadence. Once the survey teams found interesting events, they will initiate alerts to follow-up teams which can conduct very dense observations of these particularly interesting events. Such a survey plus follow-up mode has detected tens of microlensing planets. Now we are entering the era of the second-generation microlensing experiments, in which the survey teams can monitor stars with higher cadence observations. Among these second-generation experiments, KMT-net will be the most powerful one. KMT-net, an acronym for the Korea Microlensing Telescopes Network, consists of 3 1.6-meter telescopes, each with 4 square degrees of field of view. These telescopes will be located in 3 different sites and altogether can achieve 10-minute cadence for microlensing observations. Therefore, KMT-net will be able to detect exoplanets without reference to any follow-up observations. Our simulation is conducted for a simplified KMT-net experiment. In this figure, we show the distribution of planets detected in our simulation in comparison with all the planets that are included in our simulation. We found that KMT-net will be able to find more very low-mass planets, even down to Mars mass. With about 7,000 simulated events, we found that according to Ada and Lin's Core Accretion model, the fraction of planetary events in all microlensing events is 2.9%, out of which 5.8% show multiple planet signatures. The survey plus follow-up mode used in current observations have shown that higher magnification events are more sensitive to planet detections. However, our simulation shows that in the second-generation microlensing era, if the survey-only mode is used, those extremely high magnification events may become less sensitive to planet detections, even though the survey teams can achieve high cadence observations all around the clock. This suggests that although KMT-net observations can be systematically analyzed without reference to any follow-up data, follow-up observations will be essential in extracting the full series potential of very high magnification events. Thank you for watching this video. For more information, please see our paper which is posted on astro-ph.